Dear friends, welcome to Bond with Arctic Chemistry YouTube channel. In this video, I will explain the previous year questions which are repeated in HCU PG Entrance Examination in Chemistry from Inorganic Chemistry from the year 2010 to 2012. These are year-wise questions from Inorganic Chemistry. An octahedron has, this is the octahedron. Here we have 6 vertices. These are the 6 vertices and 8 phases. This one, when you connect these positions with you get 4 phases above and 4 phases below, so 8 phases. And also we have 12 edges. In plane we have 4 edges, and above plane we have 4 edges, and below also we have 4 edges. So finally we have 12 edges. When one adds dilute HCU solutions to the another solution containing equal concentrations of Cl minus, Br minus and I minus, which is precipitated most? When HCNO3 is added to the Cl minus, there is a formation of AgCl. When you react with the Br minus, there is a formation of AgBr. And when you react with I minus, there is a formation of AgI. If you take the solubility product value, this is the order. AgCl, this one has a more solubility product, AgBr less, and the less solubility product is AgI. The compound which has less solubility product, that one will be precipitated first. So AgI is the correct option. The diagonally adjacent element to beryllium that exhibits properties similar to the beryllium base. So there is a diagonal relationship between second period element with the next group third period element. Suppose if you take beryllium, this belongs to second group, beryllium, magnesium, calcium, strontium, and the next group is the boron, aluminum, gallium, indium, thallium, and this is the second period. This is the third period. There is a diagonal relation between second period element with the third period next group element. So this is a diagonal relationship. There is a diagonal relationship between beryllium and aluminum. Among the following, the most unstable molecule is. So let's take a number of electrons in the molecules and bond order. The molecule has 2, 4, 8, 6, 8, 10. The bond order will be for 2 electrons it will be 1, 4 electrons 0, 6 electrons 1, 8 electrons 0, and 10 electrons 1, and 12 electrons it will be 2, and 14 electrons it will be 3, 16 electrons it will be 2, and 18 electrons it will be 1. So lithium 2, it's a 6 electron system, bond order is 1. Be2, 8 electron system, bond order is 0. B2, 10 electron system, it has the bond order 1. And C2, the bond order is 12 electron system, the bond order is 2. Be2, since it has 0 bond order, this one is unstable. If the H and H angle in NH3 is 107 degrees, the angle between the direction of the lone pair of electrons and NH bond is. Let's take the structure. This is the NH3 and lone pair of electrons. Here the angle is given 107 degrees. Suppose if there is no deviation in the angle, let's take there is no deviation. Suppose let's take all the angles are equal. Then the angle will be 109 degrees. 109 degrees 28 minutes. It is equal to 109.5 degrees. Nearly equal. This one also 109 degrees. 5 minutes. This one also 109 degrees, 109.5 degrees. Okay, if there is no deviation. But here there is a deviation. Here there is a decrease in bond angle from 109 degree, 109.5 degrees to 107 degrees. So there is a decrease. Here there is a decrease. Here also there is a decrease. Means this angle is increased by 2.5 degrees. So we have to add 109.5 with 2.5. You will get 1 and it will be 2 and 112 degrees. It's nearly equal to 111.8 degrees. This is the correct option. Which compound among the following can act as Lewis acid as well as Lewis base? To act as Lewis acid as well as Lewis base, it should have empty orbital and a lone pair of electrons. This one has a lone pair of electrons, so it's a Lewis base. This one has empty orbital and also chlorine has lone pair of electrons. So empty orbital accepts lone pair of electrons, Lewis acid. This one is Lewis base. It has two sides, Lewis acid and Lewis base. This one has lone pair of electrons, it's a Lewis base. Here there is an empty orbital, it's a Lewis acid. So the correct option is SnCl2. The number of double bonds in C3O2 satisfying the normal valencies of the element is. This is the structure of C3O2. Here we have 1, 2, 3, 4 double bonds. Which among the following is a superoxide? O2 minus. We have three types of oxides. O2 minus, it's a normal oxide, and peroxide O2 2 minus, and superoxide O2 minus 1. Here we have O2 2 minus, it's a peroxide, and this one is O2 minus, it's a normal oxide. This one is O2 minus, it's a superoxide. This one is the mixed oxide. It's a mixed oxide of FeO and Fe2O3. Aquarius is a powerful oxidizing agent because it contains Aquarius. It is a 1:3 ratio of concentrated HNO3 and concentrated HCl. When you take HNO3 and HCl in 1:3 ratio, there is a formation of nitrosyl chloride NaCl, and there is a release of Cl2, and there is a formation of water. So this Aquarius contains NaCl and also free Cl2. This is the correct option. Which of the following cannot act as the ligand? To act as the ligand, it should have lone pair of electrons. Okay, arsenic, it has lone pair of electrons. And NO plus also has the lone pair of electrons. It's a positively charged ligand. BF3, it has an empty orbital. It cannot act as a ligand. Cl minus, it has lone pair of electrons, so it can act as a ligand. To act as a ligand, it should be Lewis base. We have to identify Lewis base. Since BF3 is Lewis acid, it cannot act as a ligand. Iodometry involves Iodometry. We have Iodometry, Iodo and Iodometry. In Iodometry, we use I2. Here we produce I2. In previous step, we produce I2. This is the main difference between Iodometry and Iodometry. In case of Iodometry, titration with standard iodine solution, and iodine as a reducing agent. Actually, in Iodometry, iodine is a oxidizing agent. Production of iodine from excess iodide by analyte. This one is not iodometry. This one is iodometry. Precipitation of iodine for gravimetric estimation. This one is not correct. So the correct option is titration with standard iodine solution. Which of the following is not a crystalline substance? Graphite, diamond, and Buckminster fullerene. All these are crystalline forms of carbon. Charcoal, it's an amorphous form of carbon. Which one among the following chlorides is dissociated to the least extent in aqueous solutions? It's a ionic solid, readily soluble, AlCl3 also soluble, zinc chloride partially soluble, HCl2 it's not soluble in water, and the solubility product is very low when compared with ZnCl2. So HCl2 is the least extent of dissociation in aqueous solution. The number of isomers having non-zero dipole moment for PCl2F3 in the trigonal bipyramidal geometry is, we have three isomers. We have three isomers, and both the chlorines are in anti-position, or one chlorine is in this position, or both the fluorine are at axial position. So these are the possibilities, three possibilities we have. So both the chlorines on axial position, remaining fluorines equatorial, and one chlorine axial, one chlorine equatorial, and the remaining fluorine, and both the chlorines in equatorial, and the remaining will be fluorine. In this case, there is a cancellation of individual bond dipole moments. So here there is the dipole moment is 0. Here there is no cancellation of individual bond dipole moments. So mu naught is equal to 0. Here also mu naught is equal to 0. So the two structures have non-zero dipole moment out of three structures. Which of the following fluorides is angular? BaF2 is linear. Sp hybridized is linear. ZnF2 also is linear. And HCF2, which is also linear. SnF2, here the hybridization is sp2, and it has one lone pair of electron, and the shape is bent shape. What is the electronic configuration of V3 plus ion? Okay, vanadium, it's 3d3 4s2. This one is argon 3d3 4s2. When you remove 3 electrons, it will be argon 3d2 4s0. So the electronic configuration will be argon 3d2. The hybridization that is common for at least one of the carbon atoms in hydrogen cyanide, sp hybridization, and carbon disulfide, C double bond S, C double bond S. Here you have two pi bonds, it is also sp, and allene, already this one is asked. So here also sp hybridization, allene, and carbon monoxide, this one also has sp hybridization. So what is the hybridization? The common hybridization is sp. Using Wade's rule, predict the structure of B5H9. We have closo, nido, arachno, and hypo. What is the formula? Closo Bn Hn plus 2. Okay, this is not possible. This one is this is possible. Bn Hn 2 minus. Next one is Bn Hn plus 4, Bn Hn plus 6, and Bn Hn plus 8. Here B5 can be written as B5H 5 plus 4. It's Bn Hn plus 4. So it's a nido. Which one of the following statements do not apply to the intrahalogen compounds? Intrahalogen compounds neutral. We have AX, AX3, AX5, and AX7 type of intrahalogen compounds. All these are neutral. If you take BRF3, it's a neutral. And it could be cationic. If you take BRF2 plus, it's a cationic. And could be anionic, IF6 minus, it's an anionic. Always obey object rule. This is not correct. If you take IF7, the number of electrons attained by the central atom is 14 electrons. It's not 8 electrons. So it's not correct. Always obey object rule is correct option. Order of increasing dipole moment among HTS, H2O, BF3. We know the structure of BF3. This is the structure, and the dipole moment mu is equal to 0. So the dipole moment of BF3 should be least. If we compare H2S and H2O, the electronegativity difference between hydrogen and oxygen is more. So the dipole moment of H2 is greater than H2S, and the least one is BF3. What is the hybridization of sulfur in SF4? Here we have to find out number of hybridized orbitals by using this formula. On central atom, how many valence electrons are there? 6 valence electrons, and 4 monovalent divided by 2. It will be 10 by 2. So 5 hybridized orbitals are there. So the hybridization will be sp3d, 1s, 3p, and 1d. So this is the correct option. The dipole moment of BRF is 1.29d, and its bond length is 178 picometer. What is the percent ionic character of the BRF bond? Percent ionic character is equal to mu observed by mu calculated into 100. So mu observed is given. This is the mu observed. We have to calculate mu calculated. Mu calculated is equal to, this one is charge on electron in the L. Here charge on electron is 4.8 into 10 to the power of minus 10 electrostatic units, and the length is given 178 into 10 to the power of minus 10 centimeters. When you convert 178 picometers into centimeters, you will get 10 to the power of minus 10 centimeters. When you calculate, you will get 8.544 into 10 to the power of minus 18 ESU centimeter. 10 to the power of minus 18 ESU centimeter will be equal to 1 dB. 1 dB is equal to 10 to the power of minus 18 ESU and centimeter. So it will be mu calculated will be equal to 8.544 dB. So percentage of ionic character will be equal to 1.29 divided by 8.544 into 100. It will be equal to nearly equal to 15%. Which among the following is the strongest acid? Sulfuric acid, hydrobromic acid, a solution of antimony pentafluoride SbF5, and fluorosulfuric acid. This one is the superacid. Superacids are strongest acids, and fluorosulfuric acid. So which is the correct one? A solution of antimony and antimony pentafluoride, and fluorosulfuric acid is even stronger than fluorosulfuric acid. An aqueous solution containing NH4Cl, FeCl3, MnCl2 is treated with NH4OH solution. The observation is that this is the reagent NH4Cl, NH4OH. This is the reagent for group 3 cations in cation separation table. Here we have Fe3 plus, this belongs to group 3 cations, so this one will be precipitated as hydroxides. We have Fe3 plus, Al3 plus, and Cr3 plus in group 3. These cations will be precipitated by using NH4Cl and NH4OH. So the correct option will be Fe3 plus. The number of elements expected in the G block of the periodic table is, we have S, P, D, F, the number of orbitals S1, and the sublevels 3, 5, and 7. So the number of electrons will be 2, 6, 10, and it will be 14. The next level is G. It will be 9, 9 into 2, 18, 18 electrons it can accommodate. So if you have G block, it can have 18 elements. Which of the following is not suitable as an antacid? The antacid should be base. The salt should be base when you dissolve in water. Sodium bicarbonate, when you dissolve, it should be a salt of strong base and weak acid. It's a salt of strong base and weak acid. Calcium carbonate, it is also salt of strong base, weak acid. Sodium sulfate, NaTH4. It's a salt of a strong acid and strong base. It's a neutral. It's a neutral, cannot act as a antacid. It's a base. It is also base. It's a neutral. Magnesium hydroxide is the base. So these three, A, B, and D, can be used as an antacid, but sodium sulfate cannot be acted as antacid. Among RbO2, AlO2 minus, SrO2, and O2 plus, unpaired electrons is present in rubidium. This one has odd number of electrons, valence electrons. Oxygen, even number of electrons. So finally, this one has odd number of electrons. Aluminium, odd, and oxygen, even. But you are adding, the minus means you are adding one electron, so it will become even. So final odd plus even. When you remove, when you add one, it will become even. And strontium, this one has even number of electrons. This one also has even number of electrons. So the total number of electrons will be even. Here, this one has odd number of electrons, even number of electrons. When you remove one electron, it will become even. So RbO2, it has odd number of electrons. It will be paramagnetic. It has unpaired electron. Which one among the given arrangements of one molecule of HCl and one molecule of HBr will give lowest energy? Okay, lowest energy here, HCl. Here the partial positive charge, partial negative charge. Here partial positive charge, partial negative charge. This type of arrangement, there is attraction between Cl minus and H plus, and also H plus and Br minus. This type of arrangement is stable and it has lowest energy. Suppose if we take this one plus plus, there is a repulsion. Minus minus, there is a repulsion. It increases energy. Here minus minus. Here also there is a repulsion. And here there is a attraction, but here the attraction, one-time attraction. Here you have attraction between H plus Br minus and H plus Cl minus. So attraction decreases energy, repulsions increases energy. Here you have two attractions, here one attraction. So A has lowest energy. For a molecule MX3 with zero dipole moment and M belonging to the second period, the orbitals on M involved in sigma bonding are the type of. We can take second period, zero dipole moment, M belong to second period. Let's take boron and BF3. If we take here, the net dipole moment is zero, so the molecule is similar to BF3, and we know the hybridization of BF3 is sp2 hybridized. In normal silicates, each silicon atom is surrounded by. This is a normal silicate SiO4 4 minus. So this is the structure O minus, O minus, and O minus, O minus. This is the structure. 4 oxygen atoms in tetrahedral geometry. It's a sp3 hybridized silicon. So C is the correct option. The number of lone pair of electrons around the xenon in Fe3 plus, Fe4, and XeO3. Let's take the number of hybridized orbitals. Xenon, it has 8 valence electrons, 3 monovalent, and we have to remove charge, minus 1 divided by 2. It will be 11 minus 1. It's a 10 by 2, so 5. It's a sp3d hybridized. So this is the shape. And we have 2 lone pair of electrons. The remaining positions will be occupied by fluorine. And if we take XeF4, this one is sp3d2, and we have 2 lone pair of electrons, and here we have fluorines. You know the structure of XeF4. And XeO3, here the hybridization is sp3, and this is the structure XeO3, and here we have a lone pair of electron, 1 lone pair of electron. So this is the correct option. Which one of the following salts will be attracted most strongly? Attracted most strongly by magnet. Magnet means that it has a more number of unpaired electrons. Let's take the salt MnSO4. It has Mn2 plus, so it's a d5 electron configuration. 5 unpaired electrons are there here, and cobalt 2 plus. It's a d7 electronic configuration. So it has 3 unpaired electrons. Zn2 plus it's a D10 electronic configuration. It has 0 unpaired electrons. Cu2 plus it's a D9 electronic configuration. It has 1 unpaired electron. So MnSO4 has the more number of unpaired electrons. It will be strongly attracted by the magnet. Which one of the following ions does not interfere with the Brown test for the nitrate ion? Okay, for the nitrate ion, in Brown test we use freshly prepared ferrous sulfate. This one contains Fe2 plus SO4 2 minus. NO2 minus nitrite ion also gives Brown test. So this one interferes about Brown test. And Br minus and I minus, Br minus and I minus, these two will be oxidized to Br2 and I2 in presence of Fe2 plus, and the Fe2 plus will be converted into Fe3 plus. So here there is a release of colored gases. These are colored gases. So these colored gases interfere Brown test. But in case of Cl minus, here also Fe2 plus and Cl minus, here also Fe2 plus will be converted into Fe3 plus, and there is a release of Cl2, but it's not colored gas, so it cannot interfere Brown test. The solving material used by the electricians in an alloy of, it's an alloy of tin and lead. Tin is 60% and lead is 40%. The correct order for increasing thermal stabilities among KTCO3, MgCO3, BeCO3 and CaCO3 is, in alkali and alkaline earth metals, as the size of cation increases, the thermal stability of carbocations increases. This is the order: Be2 plus, next one is Mg2 plus, and the next one Ca2 plus, K plus. This is the order of size. So the stability order will be K2CO3 is more stable and BeCO3 is least stable. The most probable outer electronic configuration for several lanthanides is given below. Okay, lanthanum, these are the electronic configurations which are given. The elements that can have +2 as a stable oxidation state are, okay, in which after removal of 2 electrons it gets F7 electronic configuration. Those elements can exhibit +2 oxidation state. Suppose if you take this one, when you remove 2 electrons, you will get the half-filled electronic configuration F7. So europium can exhibit +2 oxidation state, and also this one, ytterbium, when you remove 2 electrons, you will get completely filled F14 electronic configuration. Ytterbium can also exhibit +2 oxidation state. So D is the correct option. Thank you very much.